Hi, my name is Sonja Brankovich, and I'm a second-year PhD student in the Woodruff School of Mechanical Engineering at Georgia Tech. I work in Shannon Yee's Scalable Thermal Energy Engineering Lab, or STEEL. And today I'm going to be talking about my project, which is to deal with concentrating solar power systems. So what is that? When you hear solar, usually you might think photovoltaic cells, which directly convert solar energy into electrical energy. CSP, on the other hand, is a direct replacement for the heat source for a traditional power cycle. So in 2018, the Department of Energy launched a Generation 3 concentrating solar power project that incorporated several private labs and other companies, national labs, including Georgia Tech, to look at new technology that will enable higher operating temperatures for concentrating solar power systems. So basically how the system works is that you have a cool heat transfer fluid, which is cool relatively because it's typically a molten salt, that's sent up a receiver tower that's surrounded by a concentric circle of mirrors that focus or concentrate sunlight onto the heat transfer fluid, which is heated up to a much higher temperature than it originally started with. That hot fluid is then either sent directly to a power cycle where it will turn a turbine, or it'll be sent to a high temperature storage tank where it can be used when it's cloudy or nighttime so that you can get electricity immediately. So my part of the project is to look at what sort of containment or structural materials will be able to handle higher temperature salts when we moved in that direction. Because for the past generation 1 and 2 systems, we've had this problem where at 600 Celsius, the nitrate molten salts that we use start to degrade. So with new salt chemistries, we're able to go to higher temperatures and therefore higher efficiencies. The problem is that salts are very corrosive at these high temperatures, and we need to know what sort of special stainless steels or nickel-based superalloys or ceramics are able to handle these high temperature and corrosive environments. So I'm looking at the thermophysical properties like thermal conductivity of these structural materials in these very extreme environments. So thank you for listening, and we'll be back with more videos